Hello class. Alright, so this is going to be a video on solving systems of linear inequalities. These are really easy. They're a lot simpler than some of you might think. But honestly, it's just all about graphing and coloring. That's all there is to it. Alright, so to get started, let's say we have two inequalities. So let's say y is greater than 3 and x plus 2y. No, y is less than 3, and x plus 2y is less than or equal to 4. Alright, well, let's just find out what the solutions of this are. So in order to do this, we need to graph it. And let's just make a graph. Alright, let's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Alright. And I'm too lazy, so I'm not going to label all the numbers right now, but it's just by ones. Alright. So let's draw the lines. So we have y is less than 3. And because it's a less than, not a less than or equal to, it's a dashed line. So we go to y is less than 3, so we go up to 3, and we make a dashed line here. Alright, and now we can shade this because it's an inequality. So what it's saying is all the numbers that are less than y. Sorry, I'm not explaining this very well. Okay, because y is less than, you would shade underneath the line, or less than where the line is. So in this case, let's just shade underneath this line here. Now you might want to shade after you've drawn both lines, but I don't know, I do it this way. Alright, so now the second line. We need to simplify this into y equals mx plus b. So we take the x and put it on the other side. So as we get 2y is less than or equal to negative x plus 4. And now we divide everything by 2 because there's a 2 here. So we divide this all by 2. So we get y is less than or equal to negative 1/2 plus 2. Negative 1/2 x plus 2. All right. So let's just plug in 0. Let's plug in a 0 for x. So 0, 2. So 2 there. A 1 for x would be negative 1/2. Hang on, let me just use my calculator here. 1.5. So 1, it would be 1.5. 2, it would be 1. So we have another line here. So let's shade this. Actually, let's draw the line first. That's kind of important. Because it's a less than or equal to, we draw a solid line because it's an equal to. So we have our line here. All right. Now we can shade this line. And because it's less than, y is less than, we shade underneath the line. So shading here, you can just color all this in, shade all this. All right, now solutions. The way that we see what the solution of this is we see where the shades of each lines intersect. So where it's darker usually. I didn't do a super good job of drawing that darker, but let me just make that a little more clear. So in this case, when over here where the shading is really dark and where I'm coloring right now, that is where the solution is. Any number here will be a solution to both equations. But right here where the line this line here, negative 1/2, negative 1/2 x plus 2, where this goes down and this line is above it, this is not a solution. It's a solution to the first one, but not to the second one. Same with here, where y equals negative 1/2 x plus 2 is above, y is greater than 3. That means that it's only a solution to the second formula. So when you're shading, it's always where the shades intersect. Now, let me see. I mean, that's really all there is to it, to understanding whether these are, you know, where the solutions are. All you need to do is graph it, make sure that you know where to shade it. Actually, I'll talk about that real quick. So let's just say we have like y, or 3y plus, no, let's see, 2x plus 3y is greater than, or is less than 4. Okay, well, we need to get this into y equals mx plus b. So we move the x over, so we get 3y is less than negative 2x plus 4. We divide both sides by 3, so y is less than negative 2/3 x plus 4/3. No, I'm not going to graph the line, but because y is less than, we would shade less than the line, or under the line. So you would shade underneath the line. But let's say, let's say that it was greater than. Y is greater than this. So because it is greater than, you would shade greater than the line, or above where the line is. So you'd shade above the line. The shading is the same for whether it's greater than or equal to. Just remember that if it's greater than, without an equal to, it's dashed. But if it's with an equal to, it's solid. Also, I'm going to do another one with a bit of an odd example. All right, so let's say we have 2x minus 4y is greater than or equal to 8. Okay, so like I said before, we need to get this into y equals mx plus b. So we move the 2x over to this side, so we get negative 4y is greater than or equal to negative 2x plus 8. Now we need to divide both sides by negative 4. And this is where this weird rule comes in. If you divide, in an inequality, if you divide both sides by a negative number, you flip the inequality. So, in this case, you divide both sides by negative 4, so you would get y. And because you've divided by a negative number, you would flip this from greater than to less than. So you'd flip it around like this. Y is now less than. So negative 2 divided by negative 4 is 1/2 x minus 2. And now you would now that it's written this way, because y is less than, you would shade less than the line or under the line. That's really all there is to it, to understanding how to solve systems of linear equalities. Just make sure that you know how to graph and that you know how to color, which frankly isn't really that hard. If you have 3 linear inequalities, it's just where all 3 shading patterns intersect, or where it's the darkest. That's really all there is to it. I hope this helps some of you guys, and I'll see ya. Thank you.